Okay, and for example number 4, the fourth and final example. This is a maximizing profit problem. In this problem, the Boy Scouts are selling popcorn as a special for the holidays. They're selling white chocolate covered popcorn with peppermint bits in it for $10 per tin. Based off sales of another group that's done this before, they tried to sell them for the $10, and they were going to make about 1,500 sales. In order to maximize their profits, they were thinking about increasing the cost of these tins for increments of $1. So they're not going to charge things like 50 cents. They're going to say it's $11 or it's $12. Okay, but again, we'll use this as far as a marker. Okay. For every $1 increase, though, they believe that they're going to lose out on 100 sales, which means for $11 per tin, I'm then going to lose 100 people and only sell 1,400. Or if I charge an additional $2, then that would be $12 per tin, and I would only have then 1,300 sales. Okay, so we have to be careful with that and make sure we understand that. If you pay attention to the equation, again, you're going to have to come up with this equation at some point without it being given to you. So you're going to look at that first set of parentheses. The parentheses says 10 plus 1R. That comes from the $10 original cost. And then I'm going to increase the cost by $1 increments. So 10 plus 1R. The second set of parentheses comes from the sales. So we have 1,500 sales to begin with. And then it states that we're going to lose 100 sales per increase. So it's 1,500 minus 100R. Similar to problem number 2, we're going to take whatever we have in parentheses here, and we're going to find our R intercepts now because we have the variable R. So they are my R intercepts. I'm going to have 10 plus the 1R equals 0. Here again, because the R is positive, I'm going to go ahead and leave that where it's at, and I'm going to shift that 10 over, so I'm going to subtract 10. That gives me 1R, or just R, equals negative 10, which means I have an ordered pair of negative 10, comma 0. Okay, and then doing the other one, I have 1,500 minus the 100R equals 0. Here, because the R is again a minus, instead of losing that minus sign by moving the 1,500, I'm going to move the 100R. So I'm going to add 100R to both sides. It's going to give me 1,500 equals 100R. In order to get R by itself, I need to divide then by 100 on both sides, which gives me 15 equals R, or the ordered pair 15, comma 0. Okay, and as if with the previous problem for number 2, we're going to take these and we're going to go ahead and identify what these mean. So if I have negative 10, comma 0, that's telling me that I'm looking at decreasing, because it's negative, the cost by $10 per tin. Okay, does that make much sense? Because if I'm originally charging only $10 per tin, if I reduce the cost by $10, I'm saying, hey, here you go, have some free popcorn. Okay, so this would mean that it is now free, and that equals no money. Okay, the whole idea of selling these things is to make some money. So if we're giving it to people for free, we're not making any money. Okay, on the flip side, this 15, comma 0 means that I'm going to increase the cost by 15 increments, which means then I'm increasing the cost of this $10 can by 15 bucks, which means now I'm charging $25 per tin. Okay, and the $25, I'm going to put cost is now $25. Again, means that I'm not making any money. Okay, and this one of two reasons. The first one is free and we're not making any money because we're just giving it to them for free. Okay, a whole bunch of people want free popcorn. They love free popcorn. But if you have to charge $25 per tin, no one's even going to buy it. Okay, so you're not getting rid of any popcorn. Then up here, let's find the axis of symmetry. So here's the AOS. Again, I'm going to use those two values. I'm going to find the average or the mean of them. So R equals that 15 plus the negative 10, and I'm going to divide it by 2, which gives me R equals 5 over 2, which means that is 2.5. Okay. Using my intercept as well then to find the scale, I'm going to go ahead and find that over here in the bottom right hand corner. My R scale, again, I'm going to use the positive intercept value that I have, and that would be the 15 over there. So I have 15, and then I'm going to again divide this by 6 because with the graphs that I'm providing, I have 6 nice landmarks. So I'm going to have 15 divided by 6, and that gives me 2.5. Okay, so this is one of those times when we can look at this and say, okay, we can round this up to 3. However, if we look at the AOS, it is also 2.5. So if I use the scale of 2.5, then I'm going to actually have the AOS in the problem, okay, in the table and on the graph itself on one of these nice lines. If you choose not to use 2.5, that's fine. You can round to 3, but I wouldn't go much further than 3. Okay, but 2.5 is going to give us a little bit nicer values and things to work with. So let's go ahead and use 2.5. Okay, so in my table, I have my R values that I'm plugging in. This is my C of R. This is again my 10 plus the 1R times the 1500 minus the 100R. And then this is my R, comma, C of R. My input, comma, my output. Okay, and again, here now I'm going to start with 0 like always. Okay, and I need to find out how far I need to go. But again, my value here is 15, comma, 0. That's my intercept. And that's my scale. So if I take my scale and I start writing it out, I have 0. I have 2.5 at this first marker. I have 5, I have 7.5, I have 10, I have 12.5, and I have 15. Okay, so that works out perfectly and extends all the way to the end of the graph. So I'm going to have to take each one of these values and plug them into my table. So 0, 2.5, 5, 7.5, 10, 12.5, and 15. The nice thing here again is that the 15 we know is the intercept value, so we can have that already put down there. That's 15, comma, 0 using what we had before. Okay, so we need to go back then and plug in all the other ones here. So if I plug in 0, I have 10 plus 1 times 0 times the 1500 minus 100 times 0, and that's going to give me 0, comma, 15,000. If we plug in the 2.5, I have 10 plus 1 times 2.5 times the 1500 minus 100 times 2.5, Work that out. You get 0, 2.5, 15,625. Continuing, we have 5. So we have 10 plus 1 times 5 times the 1,500 minus 100 times 5. And you work that out, you get 5, comma, again, 15,000. Continuing then, 7.5, so we 10 plus 1 times 7.5 times 1,500 minus 100 times 7.5, which gives me 7.5, comma, 13,125. Plug in 10, we have 10 plus 1 times 10 times the 1,500 minus 100 times 10. You work that out, you get 10, comma, 10,000. Working the 12.5 now, so we have 10 plus 1 times 12.5 times the 1,500 minus 100 times 12.5, and you get 12.5, comma, 5,625. Okay, so from here then we again have to find what's now the C of R axis scale. So we're going to take that value that comes from the AOS and gives us the largest Y value here in the table, and we're going to divide that by 4. So I have C of R scale. I have the 15,625 divided by 4, and that gives me 3,904.25. Okay, obviously I don't want to again work with this decimal, and this is a nice enough thousands decimal that I can round it up to the nearest 100. So if I round it up to the nearest 100, then I end up with 4,000. Okay, so that's the steps that we're going to use on this side. So we have 4,000 here. Next line up is 8,000. Next line up then is 12,000. And then the last on the top line here is 16,000. And again, then trying to help us with graphing purposes here, we're going to find out what each line scale going up is. And we take that number that's on the bottom there, the 4,000, we divide that by 5, and we end up with 800. So each step going up is 800. If again you need to be that person that writes out what each step means, that's fine. So 0, 800, 1,600, 2,400, etc. Okay, again, be your own advocate. Okay, graphing the order pairs now. We have 0, 15,000. So I have 0. I go all the way up here to 12,000. I have 12,800, 13,600, 14,400, 15,200, which means I'm a little less than that. At 2.5, I have 15,625. So I'm really close to this top line here. This would be 15,200. Okay, so I'm kind of in between there. So I have here, I go in the middle there. Okay, and then we repeat here at the 15,000 for 5. So I can just go straight across from that. So I have 5, 15,000. Then I have 7.5, 13,125. So I have 7.5, 12,000, 12,800, 13,600. So I'm below that. So I'm going to be, we'll call it here, 10,000. So we have 10. Go up to 8,800, 9,600. We're a little bit above that. 12.5, comma 5,625. So we have 12.5, 4,000, 4,800, 5,600. So I'm just barely above that line. And then at 15, we're at 15, comma 0. So we have a dot right on the graph, on the axis. Again, then nice smooth transitions. I'm going to go from here. I go up and smooth it out. And then I go gracefully down to the bottom. Okay, again, stopping there, not putting an arrow. Okay, here I have an axis of symmetry that I can identify. I'm going to go ahead and make that dashed line on the axis of symmetry. So that was again at the 2.5 that we found over here. And that's nicely on the graph here. So we can do this dashed line here and identify this R equals 2.5. Okay, and again, we're going to then identify the 3 things that I need to identify: the R-intercept, the C of R-intercept, and the maxima. Okay, so let's start with that that R-intercept. The R-intercept here, we already identified, right? So that was 15, comma 0, which meant that people were going a little bit crazy. They charged $15 extra, and they didn't want to make the Boy Scouts apparently any money, because at $25 a tin, nobody even bought from the Boy Scouts, which is a shame. Finding that C of R value, then it comes from right here. So my C of R intercept is again my first order pair in my table, so 0, comma 15,000. Okay, and what does that mean in this context? That means that if I did not increase the cost at all, then my original sales, the original money that I'm making, is $15,000. Profit. Okay, without changing the cost at all, we're bringing in $15,000. Then the maxima again then comes from the axis of symmetry, and on that line, the vertex. So the vertex here is when we plug in the AOS and we get the output. So this is my maxima right here. So my maxima is that 15,625. Okay, so now the question again is, what does that mean? So that's the most amount of money that I can make okay, and that's with a cost shift we have 2.5 increments of $1, which means that I have $2.50 per tin. Okay, so now the cost is at $12.50 per tin. Okay, with problems like this, what I want you to start thinking about at the end, especially with these things, are if I change the cost of my item, is it actually worth the change in costs versus the number of clients that I'm going to lose? Okay, so in this example in particular, let's think about what that would mean. If I increase the cost by $2.50 to make all of only $625 more, I'm going to frustrate 2.5 increments of 100 people. Or that means I'm going to lose 250 people buying popcorn. Okay, let's be honest. Down the line, they're probably buying more than just the 1 tin of popcorn, right? Grandma and Grandpa like to buy that popcorn. They sit around and have a little movie and watch TV. Okay, so to only gain $625 but lose 250 customers here, and again, this is just a personal thought and process here, I would say not to do it. I would say leave that cost at $10 per tin and allow yourselves to lose a little bit of money but continue to make a lot of people happy. Okay, and that's all for number 4. That is all 4 of the examples that we're going to work with, the real world applications. If you have any questions, comments, and concerns, obviously message me and let me know, and I'll get back to you as soon as I can.